Hi, Year 9. We're going to go ahead and look at 1G today, which is on ratios. Now that we've done all this work with fractions, we're going to look at how we can put our fractions and our knowledge of fractions to use when we discuss ratios. So ratio is our key word today. And a ratio is just a comparison of quantities. Quantity just means an amount of something. And we're really looking at the same units. So we're not really changing units yet when we're dealing with ratios. It might be a certain amount of money to another amount of money. It might be students in a classroom, maybe the boys to girls in a classroom. So we're always talking about the same item or quantity, amount, different amounts, but the same units, whatever we're measuring. Ratios look like, and how do we write them? They look like one quantity compared to another quantity using a colon. All right, sometimes we also might write them as a fraction. So you might be saying, it could be, if I'm looking at fruit in a basket, I could have 10 apples to 5 oranges, right? Or this could be a ratio of 10 to 5, so 10 divided by 5 could also be another way to write it, all right? If I have 10 divided by 5, you guys know now that's going to reduce down to 2. So really what I'm looking at is a ratio of 2 to 1. So we're really simplifying them and working with them just like we did our fractions. One of the methods that we use is called the unitary method. So for example, you might have a comparison of quantities, and you might need to reduce it down to what that actually means for one unit that we're dealing with. So the unitary method, which is kind of like my apples to oranges example, 10 to 5 reduces down to 2 to 1. So I know that for every orange, I have 2 apples, right? Or for every whatever the second fruit was, back to apples. So you really can reduce it down so you know exactly how much 1 is worth, and that means you can then use it for other quantities as well. Let's look at a few examples so we know how to work with our ratios. So the first one here is we have 3 to 7. So we have a ratio of 3 to 7. I'm going to make an equivalent ratio by comparing the first amount and then comparing the second amount. So if we were thinking of this as a fraction, since we just did equivalent fractions, 3 divided by 7 is going to be what divided by 28? That's really what we're looking at. And I'll change this one to green. So our 7 is green, and 28 is green. All right? So think for a moment what we did to the 7 to get the 28. So if we realize that we multiplied by 4, we're going to do the same thing to the 3, which means we'll get 12. And that way we can put the 12 in the space provided. So when I write down 3 is in a ratio to 7, I really also mean that 12 is in a ratio to 28. So those are equivalent because they have the same scale factor to get from one to the next. Another example would be this one, where we have an empty box is going to be equated to 12, and then we have the 4 compared to the 16. So think for a moment, how did I get from 4 to 16? I know I multiplied by 4, so that means I should multiply by 4 to get from this box to the 12 as well. So what would I need to multiply by 4 to get to 12? And you guys can probably already guess, that's going to be my 3. So when I take 3 to 4 as one ratio, that's going to be the same as saying 12 to 16. So here's an example from a word problem where we actually have to set up our own ratios. So at a school presentation assembly, there were 5 times as many boys as adults. So automatically, I'm seeing this ratio of boys to adults. So I'm going to write down B to A, and there were 5 times as many boys as there was an adult. So for every adult, we had 5 boys present at the assembly. And twice as many girls as boys. So my girl to boy ratio means that I have twice as many girls for every boy. So one boy would make 2 girls there, okay? But then I could also look from beginning to end. I could say, well, I started by comparing boys, and then we compare them to adults, and then we compare them to girls. So if I put all three together in one ratio, what I'm saying is that for one adult, I had 5 boys, but I had twice as many girls. So if I have one adult and I have 5 boys, and I have twice as many girls as the boys, then I actually have 10 of the girls. So that's just a small portion of the people who are probably at this assembly, but that is the ratio of the different genders of everybody at the assembly and positions, whether they're older or younger, right? For the adults and the boys and girls. So let's go ahead and now start looking at how we can compare. For boys to adults, so B to A, we've already figured that out. That should be 5 to 1. For boys to girls, we've also already looked at that, just the other way around. So boys to girls is going to be for every 1 boy, 2 girls. For C, it says girls to boys, and we've already done that one, so 2 to 1. For D, it says girls to adults. Now this one is the first one that's a little bit trickier. We're going to have to look, okay, if I go from girls to adults, let's look over here at what we made earlier. For girls to adults, that means for every 10 girls that I have at the party, at the assembly, I have 1 adult. So that is my ratio. I have 10 girls for every 1 adult that's present. And then last but not least, we're looking at boys to the total at the assembly. So I know that if I look over here, these are all the people that I have at the assembly. So let's look back at the B to the A to the G. If these are all the people who are at the assembly, then that means we really have 16 different people. We have 5 boys, 1 adult, 10 girls. And that's just the ratio, though, for all of the other people at the assembly. But for every 16 people, because 5 plus 1 plus 10, we actually have 16 people right now that we're comparing this to. For all 16 of those people, we have 5 boys that are present. So we might have 32 people, or we might have 100 people. But basically, for every 16 people total, 5 of those people are boys. We're just going to look through 2 more examples here. One, for this number 4, we just want to make sure we always reduce. So if I always reduce, I will always have a simplified ratio. So always try to reduce as much as possible. And what that really means is look for your common factors. So if I look for my common factors, are there any common factors that are in 30 and 10? So I know that I can divide 30 and 10 by 10. And if I do that, I wind up with 3 to 1. So 30 to 10 simplifies to 3 to 1. So try the same thing with this one. 15, 30, and 10. If I want to look for my common factors, and really I want to look for my highest common factor, you guys might remember that as your HCF. My highest common factor is going to be if I divide by 5. And I just have to make sure I'm dividing all 3 values by 5. So if I do that for this one, I'll wind up with 3 to 6 to 2. And 3, 6, and 2 do not have any other common factors besides 1, so I know I did this correctly. Our last example for today has to do with decimals. And decimals and fractions, we can't compare them unless we have a similar base. So if you're looking right now, 1.6 and 0.56, we can't really compare them at the moment because one of them is rounded to tenths and the other one is rounded to hundredths. So if I'm going to wind up comparing these, I need to make them the same. I need to convert, well, at least move my decimal, so I'm really looking at the same quantities without a decimal. So what I'm going to wind up looking at is a proportion, basically a ratio of this. So in order for me to get rid of my decimals completely, 0.56, I would need to move my decimal twice to the right to get rid of my decimal completely. But if I do that to the right-hand number, then I will have to do that to the left as well. Remember when you guys multiply, or when you move your decimal 2 places to the right, you're really multiplying by a factor of 100 because that's your 2 zeros. So when we move our decimal 2 to the right, we really just multiply by 100. So by doing that, I now have 160. I had to add a 0 in because to move to the right, I had another space there. In ratio with 56. So now it's a lot clearer to see that 1.6 compared to 0.56 is really like saying 160 to 56, which almost is about a third, right? It's about a 3-to-1 ratio. So you have a much better understanding of what we're talking about than when we had decimals. So no decimals when we compare ratios. We always want to get rid of our decimals if we can. And we'll do the same thing with our fractions with finding common denominators. We'll do that in class tomorrow. All right? Have a good night. We'll see you guys next time.